Hey, it's me, Steve. It's August 4th, 2017. Time is 7:39. It's 55 degrees Fahrenheit out. This is weird. I woke up this morning, came outside. It was kind of nice. It's cool out, even though it's August, and it's not humid as fuck. Since for about the past month, it's been we've actually had a pretty mild summer. We had a hot spring, but we've had a mild summer, and but it's only been in about the 80s usually during the day, but at night it would maybe get down to like mid 60s, but usually 70. But the humidity's been through the roof like the whole time, so this is a nice change. But anyway, sorry, I digress. It is Geo-Rant time. All right, so let's see. Today's topic is going to be, I was going to do rates of sedimentation, like clastic versus non-clastic rocks, like chemical rocks and stuff like that. But I think I'm going to save that for another time. I'm going to talk very, very briefly about sedimentary structures. When we look at sedimentary rock, one of the things we can use to determine which way is up on the rock is sedimentary structures. What do I mean by up on a rock? Well, when rocks are deposited, they're deposited nearly flat, but as time goes on, they can be deformed or broken. You can get things like large-scale structures like faults and synclines and anticlines and all that stuff. And if you have a sedimentary rock, how do you know if you got say a big syncline? How do you know which way represents the top of the bed, so you can figure out in outcrop what kind of larger structure you have? And this was actually a very big problem with the Baraboo syncline, that purple quartzite I've mentioned before in geo episodes. In the 19th century, some people, because of the way the outcrops were, some people thought it was a anticline, some people thought it was a syncline. Turns out it was a syncline, and we've subsequently drilled through to it, and it's down there, so it is one. So like I said, that was a big question in the 19th century. People would just map, and they would take measurements, strike and dip, like I've said before, but without sedimentary structures, how do you know if you're measuring the top of the bed or the bottom of one? And actually, a guy named Van Heist, who ended up being in charge of Wisconsin University, figured out a lot of structural geology stuff. He actually figured most of the stuff out. He figured out stress field, stuff like that. They didn't know about plate tectonics then, but he discovered all this stuff. He showed that that a big structure like a syncline or an anticline on a huge scale, we're talking like counties or states, right? That structure is reflected in smaller structure. So he was the guy that figured it all out, and I think that's awesome, because most people think structural geology and how mountains, not how they physically form, but how they exist in space, that might have been figured out somewhere where there's a lot of mountains, and it wasn't. It was figured out in southern Wisconsin. But that aside, well, sedimentary structures, most common people use are ripple marks. When you look, like if you walk on the beach and you look down before the water gets too deep where you can't see, you'll see ripple marks. That's probably the most common sedimentary structure. And it's very helpful in determining what we call younging in a bed. Or which way is up the top of the bed. Because remember, sedimentary units are deposited a layer on top of each other, oldest to the bottom and youngest to the top, but they can be deformed after they form up, or even before they form up. But anyway, so ripple marks are one. Another common one are cross beds. Bedding usually goes like this. Cross beds will go like this. Those are planar ones. You've got trough ones. You've got all kinds of different cross beds. Those usually form in fluvial river environments or shallow marine, like on the beach. They don't form ripple marks. You'll get cross beds if you get influx of sediment, and they could be anywhere. Small cross beds could actually, if you look at cross beds and zoom out a little bit, you might actually see the ripple marks works, but smaller ones. But you can have small cross beds like teeny ones, but you can also have ones that are, you know, meters in thickness. But I'll talk about this some other time more in detail. It's getting a bit long, but that's it for today, and I hope you learned something.